Welcome to yet another video on pointers in C. In this video, we will discuss one more example which will illustrate how we can pass pointers as function parameters. So all of us have written some program to exchange or swap two numbers or two integers. So let us write a simple function which can swap two integers. So the prototype of the function will be this. We simply want this function swap to exchange two integers which are passed to it as parameters. The function definition, you will actually specify the parameters. So let us call the parameters a and b. And everyone is aware of the logic. It says you declare a temporary variable and then you do three assignments. T is equal to A is equal to B, and B is equal to C, B is equal to T. So this is our swap function. So we can simply print the values of A and B after swapping inside the function. So we will just put a statement here. After swap, A is equal to %d and B is equal to %d, and put A and B as the values. Just to see the actual values, the original values of A and B, you can put one more printf here and call this as before swap. So this function is going to swap the values of A and B. Now let us write the main function which will call this swap function. So inside main, let us first declare two parameters, say x and y, which we need to swap. We will read these parameters from the user. So you write a printf, enter x and y, and do a scanf. After we read these variables, we will call the swap function. While calling the swap function, we will pass x and y as the parameters. So once we call the swap function, we will check what the values of x and y are inside main. So again, I'll write that printf statement here. In main, the values of x and y are x and y respectively. Now let us save this program and run it. So you say gcc swap pointers.c. Please note that we have not yet used any pointer parameters as arguments to swap. So now this program has successfully compiled. Now let us run it. So it's prompting me to enter x and y. Let me enter two values. So the output that you see here is the function started executing and the first statement was before swap. So inside the function swap, the first statement was before swap, which is printing value of A as 3 and B as 5. And inside this swap function, the values of A and B have been interchanged after we have written this logic, this code. But inside main, after swap, X and Y have still their original values. So the original values are retained in X and Y. Now let us try to understand why does this happen. To understand this, let us go through the memory areas of main and swap respectively. So inside main's memory area, we have two variables, X and Y. So let me write the variables X and Y here at some addresses inside main's memory. Say X is having the address 1000 and Y is having the address 2000. We have read the values of X and Y as 3 and 5 inside main. So we'll write down the values as well. Now inside swap's memory area, there are two formal parameters, A and B. There is no other local parameter inside swap's memory area. So let us assume that these are at addresses 3000 and 4000 inside swap's memory. Now since there is a function call inside main to swap with the parameter values for A and B as 3 and 5 respectively, these values 3 and 5 are copied to the formal parameters of A and B. So A and B now are assigned the values 3 and 5 respectively. So what happens inside swap's memory area is that you have initialized the formal parameters to 3 and 5, and after the code runs, that is after this code runs, your 3 lines where you are actually writing the logic for interchanging A and B, in swap's memory area itself, the values of A and B are interchanged. So after that code executes, the values of A and B are interchanged in swap's memory area itself. So A and B are interchanged, but nothing has happened to X and Y which were there in main. So although you have called this function inside main, whatever changes are being done to the local variables or the formal parameters of the functions, to the values of the formal parameters of the function swap itself and not main. And because of this reason, the changes to the variable inside the swap function, they are not reflected inside main's memory area. So this is something that you don't want. You want the changes to be reflected inside main's memory area. So this function, which is simply going to swap the numbers, those numbers should be those parameters which are actually passed to swap rather than swap's own formal parameters. So the way to achieve this is via pointers passed as parameters. So actually address is passed as parameters. That means the prototype of the function should now change to pointers. So instead of passing simple integer variables to the function, we will now pass pointer variables to the function, the addresses to the functions, addresses of X and Y to the function. So the prototype will now change to int star, and similarly here you will have, instead of int A, int B, you will have int star A and int star B. Now once we do this, while calling the function, we need to make sure that we pass the addresses of X and Y respectively. As we saw in the last program, that if a function has a parameter which is a pointer, the type of that parameter is a pointer type, then as the actual argument it expects an address. So you are actually passing the address of x and y to swap. Apart from this, there have to be some changes have to be made to the swap function inside it, because we have now changed these a and b to pointers. So you cannot simply write a, because if I write a, it will take the address of x as the value. So if these were x and y, I would have written something like this: t is equal to x equal to y, and y is equal to t. But I do not have x and y inside swap. I have star a and star b inside swap. Okay, so I know that since a is containing address of x and y is containing b is containing address of y, we know that. So what we can do is, instead of x, we can access x's value via the pointer parameter a using the dereferencing operator, that is star a. Similarly, wherever there is an x, we will replace it with a star a. Similarly, wherever there is a y, we will replace it with a star b. Now this is fine, but there are more changes to be done. A and B are pointers, but we have to print the values represented by these pointers, not the addresses that they contain. So since we have to represent the values here, what is the value that is to be printed here? It is the value is x and y. So instead of x, you have to write star a. Wherever there is an x, you have to write star a. Wherever there is a y, you have to write star b. Similarly here, you will write star a and star b. So now this completes our swap function, which has pointer parameters. So this is the prototype. This is the function call, where we are passing the addresses of x and y, and this is the function definition, where we have made these changes. Wherever we had a and b as simple variables, we use the dereferencing operators to get the value pointed to by that pointer. Now going back to the memory map, let us look at the memory map. For this, with pointers, so swaps memory area with pointers. Okay, so again the values are a, b, x, y, and here a, b, some addresses, address 1000, address 2000, we had values 3, we have 5. And here what happens is, now what is the change here? These pointers, these are pointer parameters a and b, so I'll just use star a here and star b, so that you are able to understand the difference, that these are not simple parameters, these are pointer parameters. So 3000 and say 4000. Okay, so these variables have the value of these variables are nothing but addresses. So here you have passed address of x to a, so the value of this will be 1000. You have passed address of y to b, so value will be 2000. So as you see here that the addresses are copied into these pointers a and b. So now when we write this code, t is equal to star a, it means that t, that temporary variable t, is equal to, you dereference this memory location, that means this memory location, whatever is the value, that is 3, is assigned to t. So t takes the value 3. Next statement, star a is equal to star b, that means the memory location star a is nothing but memory location 1000. Okay, at memory location 1000, the new value will be whatever is there on the right hand side. So right hand side is star b, So star B, that means star B, when I write on the right hand side, it is the value stored at location 2000, which is 5. So this x variable takes the value 5. So this 3 changes with 5, and finally you have B giving the value t, star B getting the value t. So star B, which is nothing but y, gets the value of t. T was 3. So actually t is in swap's memory area. So t has some address, say 5000, and it is having some value. The value which was stored initially was 3. So that t value is transferred into this memory location 2000, which is inside main. So now what has happened is, actually you are modifying these values inside main's memory area, memory area. So x and y are actually modified. So their values have now been successfully interchanged, which is what we wanted. So this mechanism of exploring or using pointers as function parameters for modifying something which is passed to it, passed to the function as a parameter, some variable which is variable's address which is passed to the function as a parameter, is known as pass by address. So this mechanism is known as pass by address. The function call is known as call by address. So you can say that this is call by address. And the standard way of writing function parameters, that is when we do not have these pointer parameters, is known as pass by value, and the function call is known as call by value respectively. So hope you have understood the concept of pass by value and pass by address via this simple program. Please go through it. I will also be sharing the code with you so that you can run it yourself and see the output. Thanks for watching this video, and see you in the next video. Bye bye.